Alright, hey guys, I hope that you're having a great e-learning day. Alright, so today we're going to be talking about solving right triangles. Okay, and the big thing that you need to kind of recall from your memory for this lesson is just those ratios that we had. Alright, so SOHCAHTOA is here to stay. Okay, so SOHCAHTOA is still super duper important in this lesson. Okay, so let's just kind of focus on inverse tangent here. Okay, so for inverse tangent, I am going to kind of name these. Okay, so I have y, x, and z, just so I don't have to write kind of the segments. Okay, so if you remember way back when we first started learning this stuff, if we were looking from angle A, our tangent, so the tangent of A was that opposite, so it would be x over our adjacent, which was y. Okay, so that is still here to stay. The only difference is that this time we want to find the measure of angle A. And the way that we do that is still by this ratio. The only difference is now we're going to use something called the tangent inverse. Okay, so the tangent inverse of A is going to be equal to that x over y. Okay, tangent inverse is actually a button on your calculator. If you hit second tangent, if you have one of those graphing calculators like mine, you'll see a TAN with a little -1 above it. Okay, it'll look something like this. TAN with a little -1. Sometimes on regular calculators they have this button regardless. Maybe you just don't have to hit second. Maybe they just already have TAN with a little -1 like that. Okay, but you do want to look for a TAN with a little -1. Okay, sine and cosine work the same way. Obviously, just the ratios are set up different. Okay, but this inverse trig function helps you to find the actual measures of the angles. Okay, so that's why it's kind of important, so we can actually find the measure of the angles just by those trig functions. Okay, so we are trying to find the measure of angle H here. Okay, we're trying to find the measure of angle H. So the way that we are going to do that is through that sine inverse. Okay, so how we set this up, it kind of gives it to you. So we want the sine inverse, okay, of that 0.2. Okay, we want the sine inverse of that 0.2. So when you type that into your calculator, you should get 11.53695. Okay, I'm just going a little crazy, that way you can check it in your calculator. Okay, so 11.53, all right, as the sine inverse of 0.2. Okay, I don't want you guys to get too hung up or stressed out about numbers 1, 2, and 3. Okay, we are going to be doing mostly application problems with these. Okay, so we're a little bit more concerned about finding the actual angle measures in a given triangle, not necessarily so much as just plugging and chugging into our calculators. Okay, so if we want to find the measure of angle F, okay, we have a few options here. Okay, so we notice that we have an adjacent leg and we have a hypotenuse here. Okay, so if we go back to our good friend SOHCAHTOA, we have an adjacent and a hypotenuse. So we need a cosine here. Okay, but remember we're finding the angle measure. Okay, so in order to find the measure of angle F, we need to do the cosine inverse of that ratio. And that ratio, cosine tells us up there, okay, is the adjacent over the hypotenuse. So adjacent over hypotenuse. Okay, it's just like those ratios you had already been setting up. So that would be 24 over 25. All right, so go ahead and go into your calculator and hit cosine inverse of 24 over 25, and you will find that the measure of angle F is equal to 16.3 degrees. Okay, measure of angle F is equal to 16.3 degrees. Okay, so we found that one. We already know the measure of angle E. Okay, that one's easy. You can just write down 90. Yay, you. Okay, all right, so now let's go ahead and find angle G. Okay, so from angle G, we have opposite this time over our hypotenuse, and that would be a sine. Okay, but because we're trying to find the measure of angle G, remember we need the sine inverse of that same ratio, so 24 over 25. Okay, it's the same ratio we were coming up with on day one. Okay, the ratio has not changed, it's just that sine inverse now that has changed. Okay, so the measure of angle G, sine inverse, is going to give us 73.7 degrees. Okay, a good way to check your answer is to simply add all of the angles up together. So if I did, notice here, my three angles that I have are 90, 16.3, and 73.7. If I add all those up together, notice I do get my perfect 180. Okay, so that is a really good way to check your work right there. Okay, down at the bottom here, just note, solving a right triangle. Alright, so it means to find all of the unknown side lengths and angle measures. You can solve a right triangle when you know either of the following. So if you have just two side lengths, you can find all of those unknown side lengths and angle measures. Okay, all of them. Or if you have one side length and the measure of one acute angle. Okay, keyword being acute. So if you have the right angle, that's not really going to help you. You need one side length and one acute angle. Okay, so notice up here we have all of the angle measures, but we did not calculate that last side. Okay, so let's go ahead and do that. The easiest way to do that is probably Pythagorean theorem. Okay, so a squared plus b squared equals c squared. The reason I say that's the easiest for this one is because we are given those two side lengths. Okay, so we're given the hypotenuse of 25 squared, and that's going to be equal to 24 squared plus a squared. Okay, so 25 squared, 24 squared. Sorry, I'm having to do this in my calculator. I don't really know it in my head. Okay, so I am given that a squared equals 49. So if I do the square root, I get a equals 7. Okay, so my side length, GE, is equal to 7. Okay, this is A or GE, whichever one. Okay, so this is a special kind of triangle because notice that I have all happy, perfect whole numbers, so it is indeed a Pythagorean triple. Okay, if you feel like you need more practice on this one, go ahead and visit number 5. Okay, so here we are on page 2. Okay, so we are going to work through number 7 together and number 11. Okay, and then I'm going to turn you loose to do the rest of this assignment. Okay, so we need to find all the angle measures here. All right, so we're going to start with angle A. All right, you can start at any one. I'm just choosing A. Okay, so angle A, if I want to find, I need the opposite over the adjacent. Okay, and I know from SOHCAHTOA that that indeed is tangent. Okay, that's my opposite over adjacent. So I need the tangent inverse. Oops. The tangent inverse of 12 over 6, right, because that would be my opposite over my adjacent there, okay, and the tangent inverse of 12 over 6, so the measure of angle A is equal to 63.4 degrees when you plug that into your calculator. Okay, so 63.4 degrees, excuse me. All right, so if you haven't figured out by now, it is essential that you buy a calculator. Okay, it is very essential that you buy a calculator. All right, so if we look at C, we notice that 6 is across and 12 is adjacent. Okay, so we're going to still use, for the measure of angle C, we're still going to use the tangent inverse. Our ratio is just going to flip. Okay, so it's going to be 6 over 12 this time. Okay, and when you type that into your calculator, you get that the measure of angle C is equal to 26.6 degrees. And that checks out because when I add all my angles up, I still get to 180. Okay, Finally, we are going to calculate A over here. All right, so notice that A is our hypotenuse, okay? So we have A squared plus B squared equals C squared. Okay, I'm actually going to rename this C since it is the hypotenuse. That way I'm not super confusing you, okay? So this is going to be our C, okay? All right, so A squared, so 6 squared plus 12 squared is equal to C squared, okay? So that gives me 180 is equal to C squared. I'm going to take the square root of both sides, and I get that C is equal to the square root of 180. However, please, please, please make sure that we're writing our answer in simplest radical form. Okay, so I know that I can take some things out of this, yes. Okay, most of you like making factor trees. That is not my preferred method, but since that's your favorite, I will go ahead and do a factor tree here. Okay, so I know that I get 9 and 20, and I can separate 9 into 3 and 3, and that forms a pair. And I know that I can split 20 into 10 and 2, and I can split 10 into 5 and 2. Okay, so I get a pair of 2's and a pair of 3's. So I get 2 times 3, and then I'm left with a 5 still under the radical. So simplified out, C is equal to 6 radical 5, since I can multiply these 2 on the outside together. Okay, so that gives me that 6 radical 5. Okay, so now I have found all of my missing angles and sides for number 7. Okay, 8, 9, and 10 are very, very, very similar, so I'm not going to go over those. But if you get stuck, really refer back to number 7 or the one that we did on the first page. Okay, finally number 11 about a boat. Okay, so a boat is pulled on a dock, okay, 12 feet above the deck of the boat. Okay, so here's that 12 feet. All right, when the winch is fully extended to 25 feet, so that is this way, what is the angle of elevation? Okay, now the angle of elevation sounds like a weird term, but basically it is just this angle right here. Okay, the reason that it's this angle right here is because it is, you want the angle that is going up towards that winch. Okay, so that it would be our angle of elevation. So we are trying to find that, so let's just call that angle A. Okay, so we have, if you notice from angle A, we have the opposite side. So if we go to SOHCAHTOA, we have the opposite side, so we know that we're either going to use sine or we are going to use tangent, since those are the only ones that have those O's. Okay, and we're also given the hypotenuse, so that limits us now to sine, okay, because that's the only one that has opposite and hypotenuse in it. Okay, so we know that we're going to use sine. Okay, so you want the sine inverse, yes, because we're trying to find the angle, and that ratio would be 12 over 25. So the sine inverse of 12 over 25, when you plug that into your calculator, you should get 28.7 degrees. Okay, so that would be the angle of elevation from the boat to the winch. Okay, if you're still not sure how to calculate the angle of elevation, it is really important that you know how to do it. Just know that you're going from the boat to the winch, and it's an upward angle, so that's how you know that you're looking for this angle right here. Okay. All right, I hope that you guys have a great rest of your e-learning day, and I will see you on Friday.